2, 2 and 1.5. This is the distance which has been given to us. Next, let us go for the shear force diagram on this particular tabletop. Here there is a mistake of -5 is there, so please bear me about this one. Let us go ahead for the next of shear force diagram. Come on to the tabletop. The given beam which is of overhanging beam, this load is of 20 kilonewton. This moment which is acting is as 20 kilonewton into meter. Distances are 2, 2 and 1. Baseline. This reaction is known to us. The reaction that is of RB which is of 22.5, RAV which is of -2.5. So we know over here downward direction 2.5. We know this is up 22.5. Now first one, reaction 2.5 which is acting itself gives me the value of shear force over here 2.5. Between A, B and center point of C, between A, C and B not a single force is acting. The variation of shear force which is given by horizontal straight line. Next, sudden change will be there because of application of 22.5. So -2.5 plus 22.5 we got 20. The answer comes to be 20. And between B and D no load, it gives it constant straight line, and sudden change will be there over here 20 plus minus. So this is my shear force diagram. Refer carefully. This is the shear force diagram. This distance is of 1.5. So repeat, 2.5 goes downside, no load, horizontal straight line, upward. So here -2.5 plus 22.5 we got 20, constant 20. You got this ordinate. This 22.5 is the reaction. So now let us go ahead with the bending moment diagram. Please on the tabletop. This is my baseline. All the positive values are drawn above the baseline. All the negative values are drawn below the baseline. Now first, at A point support itself is 0. So bending moment at A point is 0. Because load multiplied by perpendicular distance is 0. Next, the bending moment at C, carefully visualized. At C there is a concentrated moment is acting. So when there is a concentrated moment is acting, tabletop please. There is a concentrated moment is acting at that particular stage. There is a sudden change in the bending moment diagram will be there. So this is C point. Moment at C just left is equal to 2.5 into 2. That is the ordinate which is of 5. But what is the nature? Then section left anticlockwise, hogging nature, negative sign. So this ordinate comes to with me is of 5, and this relation which has been given as inclined straight line, as such there is no load is acting. Now when we go on the just right side, I have to add 20 in the value of 5. So minus 5 plus 20, which gives me the answer of plus 15. So this ordinate gives me plus 15. Now let us be found out at B. What will be our answer? So moment at B is equal to minus 2.5 into 4 plus 20. This give me the answer is F plus 10. See the figure. Now see the figure carefully. Here the anticlockwise moment is acting. Here also the anticlockwise moment is acting. Hence we can plot this diagram in the next page. Please visualize over here very carefully. I will draw the figure over here. The loadings are 20 kilonewton into meter, 20 kilonewton. Distance is of 2 meter, 2 meter, 1.5 meter, and this ordinate is of 2.5 downside. Why we are making the cross over here? Because while we finding out the reactions, we are assuming always upward sign of the reactions, but finally when we found out the reactions, we got the values of negative. Please refer on this slide, on this PPT, that reaction of RAV, which is of minus 2.5. Minus 2.5 means that upward sign which is goes wrong, and we have to take the downward of that. So we got it downward 2.5. So on the tabletop please, 22.5 is this particular reaction. So please draw the dotted lines. This is my baseline. Once again, this ordinate is 0, as we know, because the force multiplied by perpendicular distance is 0. Now 2.5 into 2, that ordinate comes to be 5, minus sign below baseline, 5. Next, just right side, this both having of same nature. So minus 5 minus 20, we can achieve minus 25. So we can got minus 25, minus sign below baseline. When we go at this particular point B, then moment at B is equal to minus 2.5 into 4 minus 20, and we got that value is of minus 10 minus 20, that is of minus 30. So we got the ordinate over here which is of minus 30. Once again minus 30, that is the below baseline. And finally this value having an inclined straight line is over here. So refer the figure very carefully. So from this we can find out the shear force diagram and bending moment diagram we can plot by using the concept of static equilibrium. Now before we proceed further about the relationship between SF and BM diagram, let us be understood one basic problem over here. Next problem. See the problems. This problem is very much easy and anybody can solve because this is a problem of simply supported beam. What is this problem status? Intention is to find out the shear force at 1 point, at 2 point, at 3 point, at 4 point, at 5th point, at 6th and 7th. Both are nearer, means it is just left and just right. Then 8th, 9th and 10th point. We have to find out the value of shear force at all these points and bending moment at all these points. Refer the next figure. I think all of we can plot the shear force diagram and bending moment diagram easily. As such, a single point load is there. So between these 2 points no load is there. It is given by horizontal straight line. Then there is a sudden drop will be over here, and this is also a horizontal straight line. Ordinate. First of all, we have found out the reactions, and then we have to incorporate it, those reactions over here. The reaction is over here is of 8 kilonewton, and the reaction which is of 12 kilonewton. We can find out these two reactions with the help of equilibrium conditions. Now very carefully visualize this one. What is the area of this rectangle? Please understood. The area of this rectangle is 12 is the meter multiplied by the ordinate. 12 into 8, that is of 96 kilonewton into meter, and the same 96 kilonewton into meter we can achieve as the maximum magnitude on the bending moment diagram. Also visualize the area of is this rectangle. This area of rectangle is, please note it down, this vertical ordinate which is of 12 kilonewton, while this distance which is of 8 meter. So 12 into 8, 96. So area of both the rectangles are same. This is the first observation. Second, area of shear force diagrams gives me the maximum ordinate of bending moment diagram. This is the first observation that we can notate from this relation between SF and BM. Now let us proceed further with the relation between bending moment and shear force. Before we proceed further, refer the particular figure. What is this figure indicates? This figure indicates that a beam which has been given to me, I have to take a central part X where the loading, any kind of loading which is given to me in the region of delta X. Then what is the moment and force acting at this junction? What is the moment and force acting on this junction? And the free body diagram of this particular part which has been shown over here. So delta X is the length of the short section. The M is the bending moment acting on the left side, while M plus delta M moment is acting on the right side. If F is the shear force acting over here, then F plus delta F, that is the shear force acting over here. Now, the load acting on this section, which is of delta X. We have to establish the correlation between F, this delta X, M, and as well as the load, that is the W into delta X, that is the total load acting for this section. Because of the limitation of the time, today we have to stop. We will discuss much more, and we will discuss how the relationship will be established between M, F, delta X and W in the next session. So today friends, we have discussed the basic of how to plot the shear force diagram, bending moment diagram for the overhanging beam with point load, UDL, UVL and concentrated moment. Thank you.